Now let's look at the division of complex numbers. Over here we have one complex number divided by the other, 1 plus 2i divided by 3 minus I. How do we solve this? The goal is to omit or eliminate the I from the denominator. So the first thing we do is to find the conjugate of the denominator. And when we say conjugate, what you just do is that you negate the I part of the denominator. So over here is 3 minus I. If you negate this negative I to become positive I, then you multiply both the numerator and the denominator by 3 plus I. We expand the bracket nicely here. We distribute 1 to 3 plus I. We also distribute 2i to 3 plus I. We do same for the denominator. But what's beautiful about this kind of questions is that 3 minus I times 3 plus I always is what we call the difference of two squares. So you can just take the 3 and you square that minus the I, and then you square that. You get the same answer as multiplying 3 minus I times 3 plus I. Get the same answer for that. Now we have 3 plus I plus 6i plus 2i squared. But don't forget, I squared is always equal to -1. So we replace I squared with -1 over here. So I squared becomes -1. And then the I squared over here also becomes -1. Okay, so -1 times 2 is -2. That's what we have here. 3 minus 2 is 1. And then we have the 7i here. 9 plus 1 is 10. You can divide the numerator by 10, and then you have 1 over 10 plus 7 over 10i. Now, if you are asked to find the real part of 1 over 10 plus 7 over 10i, the real part is the part that doesn't have an I, which is 1 over 10. The imaginary part is the part that has the I as a coefficient, that's 7 over 10. So let's try two more questions. We have 1 over I root 3, or which is the same as 1 over root 3i. If we are asked to simplify this, what we do is that we multiply the numerator and the denominator by the denominator. Over here, we are not going to find the conjugate anyway. So when we do that, we have 1 times root 3i, which is root 3i. Root 3i times root 3i, any number times itself is the number squared. So we have root 3i squared. Now, root 3i all squared is the same as root 3 squared times I squared from indices and logarithm. Now, root 3 squared is 3, and then I squared, we know that that is -1. And that is our answer basically. So root 3i over -1 over -3, which can also be written as -1 over 3 times root 3i. Let's take the last question. We have 1 divided by 2 minus I. Over here, we'll find the conjugate of the denominator, which will be 2 plus I. We said you always negate the I part. So multiply both numerator and denominator by 2 plus I. So we have 1 times 2 plus I, which is 2 plus I, and then 2 minus I times 2 plus I. That is difference of two squares. And for difference of two squares, you just take the first part, which is 2, you square that, minus the second part, which is I, you square that. So I squared will be -1 over here. Let's move up. So we have 1 plus -1. Don't forget that there's already a negative sign here. So negative will give positive. So 2 plus I over 1 over 4 plus 1. That will become 2 plus I over 5. Now that's basically the answer. 2 over 5 plus 1 over 5i. The real part of this answer is 2 over 5, the part that doesn't have the I, and then the imaginary part is 1 over 5, the part that has the I. Now for this question over here, the imaginary part is 0. You should keep that in mind. So from II, which is question 2, the imaginary part is 0. It has only the real part, which is negative root 3 over 3, or -1 over 3 times root 3. So that is that for today. Thank you for your time. All the best.